Hey everybody, Dr. O here, and welcome to this video on ABO blood typing and matching. When we do ABO blood typing, we're going to be taking a little bit of our blood and we're going to drop it into a container that has serum and either anti-A antibodies in it or anti-B antibodies in it. And what we're looking for is a reaction or not. And that reaction tells us that we have the presence of the antigen on our red blood cells. So if we get an agglutination reaction when we drop blood into the container that has the anti-A antibodies, and that lets us know that we have antigen A on our blood. If we put a drop of blood into the container that has the anti-B antibodies, and that tells us that our blood has antigen B on it. So if we take our little drop of blood that we see here on the screen and we drop it into our first container of serum and anti-A antibodies, we're going to look for a reaction, and this is an example of a agglutination reaction. So this tells us that our blood is positive for antigen A. Now we're not done because remember we're looking to see if there's antigen B on the blood too. So we're also going to take some blood and we're going to drop it into another container that has the anti-B antibodies in it, and we're going to see if it reacts. And in this example it did. So our blood is positive for both antigen A and antigen B. And what type of blood is that? Well, that makes it blood type AB. Let's take a look at another one. So we're going to run through the same scenario where we have a container that has anti-A antibodies in it and anti-B antibodies, and we're going to see if we get a reaction. So let's take a drop of blood and drop it in the container with the anti-A antibodies, and we got an agglutination reaction, so we know that the blood is going to be positive for antigen A. So let's do the same thing with anti-B antibodies and see what we get. And in this case, we got no reaction. So this is what it looks like when our blood does not have antigen B on it. So we didn't get a reaction with those anti-B antibodies. So what is our blood type in this scenario? Our blood only reacted with the anti-A antibodies, which tells us that we have only the presence of antigen A, which means our blood type is type A. In this scenario, we'll take our blood, we'll drop it in the anti-A antibody vial, and we got no reaction. So we know that our blood has no antigen A on it. And if we do the same thing with our anti-B antibodies, drop that blood in there. And in this case, we did get a positive for antigen B. So this makes our blood type type B. So let's try another one. So we drop our blood in our anti-A antibody vial. We got no reaction, so we have no antigen A on our blood. And we're going to run it through anti-B as well. And we see that we got no reaction here either. So this means that the blood has neither antigen A or antigen B on it. And therefore, our blood type is going to be blood type O. In addition to testing for antigen A and antigen B, we can also test for antigen D, or the Rh factor. And we're going to see the same sort of reaction with that as we did with antigens A and B. And it's the same sort of scenario where you'll have a container that has some serum plus the anti-D antibodies in it, and you're looking for that reaction. So let's try our hand at doing some blood typing with ABO and the Rh factor. So we take our sample of blood and we drop it into our first container, and we see that we are positive for antigen A. And we do the same thing with our second bit of blood in anti-B, and we're positive for antigen B as well. So let's see what we get now with the Rh factor. Same thing. We're going to take our blood and drop it into the container that has the serum and the anti-D antibodies in it and see if we get an agglutination reaction or not. And in this case, we did get an agglutination reaction, so we are positive for antigen D. So what is our blood type? Our blood type is AB positive. Let's try another one. So our blood is going to be tested first with the anti-A antibodies, and we see that we got an agglutination reaction, so we have antigen A on our blood. And we'll do the same thing with the anti-B antibodies, and we got no reaction with this one, so we do not have antigen B on our blood. Now let's test our RH factor and see what we got. And we got a positive here with the RH factor. So that makes our blood type A positive. Let's try this one. So we'll take our blood and we'll drop it in the anti-A antibodies, and we got no reaction. So no antigen A on our blood. Let's do the same thing with the anti-B antibodies. And here we got a reaction, which means that we have antigen B. Now we're going to see if we have that RH factor or not. Take our blood and drop it in. And we have no reaction here. So in this scenario, our blood type is B negative. That's correct. So let's give this one a shot. So drop our blood into the anti-A antibodies, and we got no reaction. And we'll do the same thing for anti-B antibodies. And we got a reaction, so we know we have antigen B. And we'll drop it into our RH factor. And we got a positive for that. So our blood type is B positive. So let's try a couple more. So we'll take our blood, we'll drop it into the anti-A antibodies, and we got a reaction, which means we're positive for antigen A. And we do the same thing with our anti-B antibodies. And we got a reaction, so we're positive for antigen B. And now for our RH factor. And we got no reaction with that. What's our blood type? AB negative. And here's our last one. So let's try anti-A antibodies. And we got no reaction. And our anti-B antibodies, no reaction. So what are we so far? So far we're type O, because we don't have blood that has either antigen A or antigen B. Now we're going to find out if we're O positive or if we're O negative. So let's go ahead and test our RH factor. And that is also no reaction. So we do not have antigen D. So what's our blood type? O negative. So the whole reason we do blood typing is ultimately so we can do blood matching. For example, when a patient needs to receive blood, need a blood transfusion, we need to be able to make sure that our recipient is getting a good match for their blood type. So let's go through a couple of examples of that. So here we have a recipient's blood. We ran it through the typing, and this is what it looked like. And we can say that here's a possible donor here. We tested their blood. This is what it looked like. And then here's donor number 2. And then we have donor number 3. So we have 3 possible donors. We have 3 donors. We have 3 possibilities here. So it helps me to actually go ahead and label the blood type when working through problems like this. So I'm going to do that now. So when we look at the recipient's blood, it didn't test positive for either antigen A or antigen B or even the RH factor. So our recipient's blood is O negative. When we look at donor number 1, their blood tested positive for antigen A, but not the RH factor, so they're going to be A negative. Donor 2's blood is identical to our recipient, so we're O negative. And donor 3 blood tested negative for antigen A and antigen B, but it did show positive for the RH. So we are O positive in this scenario. Now when we look at each one of these donors, we need to figure out if it's a good match for our recipient or not. So we're going to look at donor number 1 for starters. And when we look at donor number 1, we can see that donor number 1's blood tested positive for antigen A. And what that means is if we were to give donor 1's blood to our recipient, the anti-A antibodies in the recipient's blood would create an agglutination reaction with donor number 1's blood, just like it did on the screen right here. So donor 1 is not a good match for our recipient. Now donor 2's blood is identical to the recipient's blood, so this is a good match. And then we look at donor 3's blood. They're O, just like our recipient, but we have an issue with the RH factor. Now, when we look at this, we can see that our recipient didn't have any antigens present for the RH factor on their blood. But when it comes to RH factor, we don't know for sure if this recipient is making antibodies or not. And there's a possibility, slim possibility, that maybe this recipient had an exposure to the antigen D, the D antigen previously, and now they've developed antibodies, but we don't really know that. We know that their blood doesn't have antigen D on it, but we don't really know how it's going to respond to a blood type that does have antigen D. And we can assume that even if they've not been exposed to antigen D, if they are exposed this time, they're going to create a reaction in the recipient's blood. So donor 3 is not a good match, and it's because of the presence of the antigen D on the blood. So even though the ABO portion matches our recipient, we cannot give RH positive blood to an RH negative recipient. So let's take a look at what we have here. So we've got a recipient, and this is what their blood tested like. So we have the presence of antigen A and the presence of antigen D, the RH factor. All right. Now here's what donor blood, donor number 1 looks like, and donor number 2, and donor number 3. And like I said, I like to go through and label these blood types. Kind of helps me think through things. So I've already stated that the recipient is going to be A positive. When we look at donor number 1, it didn't test positive for antigens A or B, but it did for the RH, so this is going to be O positive. Donor number 2 tested positive for antigen A, but that's it. So we're going to be A negative. Donor number 3, we tested positive for the antigen B and the antigen D, so we're going to be B positive. All right, so now let's do an analysis and see which of these donors is going to work with our recipient, if any of them. All right, so in the first circumstance, our O-type blood is actually a pretty good match. We've got an RH positive giving to an RH positive, that works, and our donor doesn't have either antigen A or antigen B on it, so I'd say donor number 1 is probably a pretty good fit for our recipient. Now donor number 2 is A negative, our recipient is A positive, so we're not going to have any problem with the presence of the A antigen on donor 2's blood, and because we have an absence of the antigen D, that's not going to be a problem either. So actually A positive can take from A negative. Now let's look at donor number 3. Now donor number 3 doesn't have the A antigen, but it does have the B antigen, and it does have the D or the RH factor on it. So we've got a problem with donor number 3, and the problem is this B antigen that the blood tested positive for. So if we were to give donor 3's blood to our recipient, the presence of the B antigen on the donor's blood would create a reaction with the anti-B antibodies that are going to be present in our recipient's blood. And how do we know that our recipient has anti-B antibodies in it? Because their red blood cells lack antigen B. So for donor number 3, we got a problem right there, and donor number 3 is not a good match, but the other 2 are. Okay, in this scenario, we have a recipient that tested positive for the antigen B and nothing else, so we're B negative here. If we look at donor number 1, they tested positive only for the RH factor, so that's going to be O positive blood. Donor number 2 tested positive for the A antigen only, which means we're A negative. And then donor number 3 tested positive for the B antigen and the D antigen, which means that this blood type is B positive. Now if we look at donor number 1, we've got the issue not with the antigen A or the antigen B. There's no problem there because these red blood cells don't have that. But we do have a problem right here with the D antigen. The presence of this RH factor can create a problem for our recipient. So this is the problem with donor number 1. Donor number 1 is not a good match. Donor number 2 tested positive for the presence of antigen A on these red blood cells, which is going to be a problem with our recipient, because when our recipient didn't respond with antigen A, we can assume that their blood plasma is going to have the anti-A antibodies. So donor number 2 doesn't work because of the presence of antigen A. Now, donor number 3 is B, just like our recipient, but it's B positive. And the problem with that is not the presence of the B antigen, but the presence of the RH factor. So this is a scenario where you have an RH positive donor trying to give to an RH negative recipient. And that means that the presence of the RH factor on the donor's blood has the possibility of creating an allergic response in the recipient. And we don't want that. So in this scenario, none of the blood types are a good match for our recipient. And in this scenario, our recipient's blood tested positive for all of the antigens, antigen A, antigen B, and the RH factor, which means that our recipient's blood is AB positive. Now, donor number 1 tested positive only for the D antigen, so we are O positive here. Donor 2 tested positive for the B antigen only, which means we're B negative blood type. And donor number 3 tested positive for antigens A and B, but not the RH factor, so we are AB negative. So let's see how this is going to work. Now we know that the lack of antigens A and antigens B is no problem, and we have a match in our RH factors, so donor number 1 is perfect. Donor number 2 doesn't have antigen A, but it has antigen B, which is fine because our recipient has antigen B, and we don't have to worry about the RH factor because an RH positive recipient can take RH negative blood. So donor number 2 works out just fine too. And if we look at donor number 3, it has antigens A and antigens B, just like our recipient. It's lacking the antigen D, but that's fine because an RH positive recipient can accept RH negative blood. And in this case, we've got all 3 of our donors that can give to our recipient. And you might notice that AB positive is known as the universal recipient because it has the presence of all the all the antigens on its surface of its red blood cells. It will not make the antibodies, which mean it will not reject or create agglutination reactions with any blood that's given to this particular recipient. All right, so let's do one more. Now in this case, we've got a recipient that tested positives for antigens A and B, but not for the RH, so we're going to be AB negative. And if we look at donor number 1, we've got an O positive. Donor number 2 is A negative. And donor number 3 is B positive. So who can give to the recipient? Well, there's no problem with donor number 1 when it comes to the A and the B antigens because this particular blood type doesn't have any. But there is a problem right here with the RH factor because we cannot give RH positive blood to an RH negative recipient. So donor 1 doesn't work. Now donor number 2 has tested positive for antigen A only. Don't have to worry about antigen B. And we're RH negative, which is fine, which is a good match for our recipient. So donor number 2 is a good match. Recipient number 3 tested positive for antigen B and antigen D. Now B is not a problem in this scenario, but this antigen D is. And the reason why is that we don't want to give RH positive blood to an RH negative recipient. So donor 3 has a problem right there. And that's that. I hope you found this video helpful, and I'll see you next time.